So we'll start off by substituting the values into the calculator. To do so, we hit the button Stats. This is an edit feature, so we'll hit Edit. And in the list 1 that's highlighted, I'm going to put the x values, which were 1, 2, 3, 4, 5, and 6. Note that I just rewrote or retyped right over the existing values. If you want, you can clear that list, but it's just as easy just to type over. In list 2, we're going to put the y values and make sure that they correspond. So we have 1, 6, 2, 15, 3, 22, 4, 21, and 6, negative 29. Now I see that I made a mistake because now I see 5's at negative 29. So in going back through the list, I see that 5 should actually be with a 6, so I just simply type over, and then 6 has the negative 29, like so. So that just makes sure that you troubleshoot your answer once you're done. Now what we've done at this point is we have told the calculator, here's the data. Now we have to tell the calculator what we want it to do with the data. So again, I'm going to hit the button Stats in the center. Now I'm going to do a Calculate command. And from our finite differences, we now know that we're going to do a cubic regression. So I go to number 5, cubic regression. I hit Enter. What we'll see here is the X list is list 1, as highlighted. The Y list is list 2. We can store the regression equation by going to our vars, function, and y1. This will then take our equation and automatically put it in y1 for us. And then when we're ready, we're going to hit Calculate. And from here, you can see the cubic polynomial in standard form. The a value is -1. We have b, or the coefficient of the x squared, is 5. C is 1. D, or the constant, is also 1. The r squared value is actually important for us because the r squared value is actually telling us that this polynomial, since the r squared is equal to 1, is passing exactly through all those points. So when we're doing problems that are table data, such that we're told there's a polynomial that passes through these points, the r squared value should be equal to 1. However, when we get into real life applications and word problems, the r squared value might be a 0.9 or a 0.8, which means they're real close, but not exactly passing through, but it's sufficient enough to model the situation. Speaking of modeling the situation, we'll see if we hit y equals at this time. Our formula, or our polynomial for this situation, is already in there for y1. And if I use the graphing feature, I could see I get part of that. If I wanted to see the full thing, I can increase my y max. So that way I can see some of the turning points. And you can see I can almost see that local maximum. So I'm going to go a little bit higher to 30 for my y max. That way I can see that turning point. And I would only need to do that if I needed to calculate a local max or local min.